Okay, so today's notes are on complex numbers. Our content objective is to identify and perform operations with complex numbers and find complex solutions. And our language objective is to correctly define and describe complex numbers. So before we dive into complex numbers, let's talk about one of their critical components, the imaginary unit. So the imaginary unit is the square root of -1. So square root of -1 is I. So it's this little cursive fancy I here. So whenever we see the square root of -1, it's equivalent to I. So that's our imaginary unit. That's going to be kind of critical for this whole lesson today. So with that in mind, we know I squared would be equal to -1, because the square root of -1 times the square root of -1 is -1, the square root of -1 squared, which is just -1. So these are going to be two important bits of information for performing operations with complex numbers today and finding complex solutions. So first critical component, square root of -1 is I, it's our imaginary unit, and our second critical component, I squared, is equal to -1. With that said, one thing that's important to know about the imaginary unit is that for any number a or positive number a, the square root of -a would be equal to -1 times a. So you can separate that negative from the number, and then that can be separated using our multiplication property of square roots or roots. And so then we can say the square root of -1 times the square root of a, which is just I square root of a. So here we have an example. Square root of -5 is just I root 5. So basically what this is allowing us to do, whenever we see a negative under a root, or sorry, a square root, we can take it out and write I in front instead of keeping that negative under the square root. So we're learning about this because, as we saw with quadratic formula in our discriminant, sometimes we will have no real solutions. So when we have no real solutions, we will have imaginary solutions. So we're learning how to solve for the imaginary solutions for the situations where we don't have any real solutions. So that's what we're going to delve into today. So solving those problems when we have no real solutions, only imaginary, or we have negative values under a discriminant. So first, I want to practice simplifying some radicals where we have negative values. So I want to simplify negative or square root of -18 and the square root of -12. So try it out on your own. I'm going to go over it now. So as you know, there's a few different ways to do this. You can make a factor tree, or if you recognize a perfect square that goes into that, you can do that. So I'm going to first start out by separating the negative from the rest of the numbers, and I recognize that 9 and 2 make up 18, and 9 is a perfect square, so I'm going to break that into 9 and 2. I'm going to now take the square root of these two things. So square root of -1 I know is I, square root of 9 is 3. You always write the number first and then I, the imaginary unit. It's like a variable. And then you have the square root of 2. That stays under the radical because there's no pretty square root of 2. That stays as it is. So you always put the number first, the imaginary unit second, and then square root of whatever's left. So here we're going to do the similar process. I put my negative separate, and then I know that 4 is a perfect square that goes into 12, and then 3. If you broke it into a factor tree, that's just as well. That's perfectly fine. And then I know when I take that out, I'm going to have I, and the square root of 4 is 2, so I have 2I, and then root 3 stays under there. So that would be my answer. So these are our simplified radicals from these quick checks. So now let's talk some more about complex numbers. So we learned about the imaginary unit. Now let's talk about complex numbers. So complex numbers are written in the form a plus bi, where a and b are real numbers. So a and b are real numbers. So we'll have a plus bi. This is the real part. And this is the imaginary part. So that might be somewhat intuitive. The part with the I is the imaginary part. The part without I is the real part. So we can talk about these. So these fall into a few different categories. I'm going to spend just a minute on this, not too long, because this is not going to be super critical in our practical practice or in our practice. But real numbers are numbers that have no imaginary component, so their imaginary component is 0. Imaginary numbers are numbers in this form, so a plus bi, so they have both a real and imaginary component. And then within imaginary numbers, we have pure imaginary numbers. And those are parts with no real component, so they only have an imaginary component. So these would be like our examples up here. So these are all one term, they're all being multiplied. So these are pure imaginary numbers because they have no real component, they only have an imaginary component. The ones we're going to learn about in a second, or practice working with in a second, have both imaginary and real components, or imaginary numbers, so they're a little more complex, or complex numbers. So let me flip the page so I can go over how we're going to perform operations with these numbers. So even though we're not going to have to do this very often when we're solving quadratics, we're more going to need to simplify radicals in order to, or that's where we're going to be using complex numbers, and is when we're solving. Eventually you'll learn more with complex numbers that you'll need to do perform other operations. So we're going to work with that some today as well. So we're going to go with practice adding and subtracting complex numbers. So this is just like adding and subtracting terms with variables, or combining like terms. You're only going to add and subtract, or add or subtract like parts. So you only combine real with real, imaginary with imaginary. You don't combine other ways. So our example, I'm not going to write steps out. I'm just going to show you how this will work. If I had 5 minus 3i, this complex number, minus, so I'm going to keep my complex numbers in parentheses for a second, minus 2 plus 4i. I'm going to treat these just like they're normal binomials, and I is just a variable. So this is going to be pretty straightforward. So to get rid of these parentheses, I need to distribute my negative. So I end up with 5 minus 3i plus 2 minus 4i. I'm going to combine imaginary with imaginary, real with real. 5 and 2 becomes 7. Negative 3 and negative 4 becomes negative 7i. And that would be my answer. I never combine real with imaginary or vice versa. So then that just stays as it is. So let's do a quick check with that really fast. I want you to add 7 minus 2i plus negative 3 plus I. Try that on your own. I'm going to go over it now. Since I'm not subtracting, I don't need to distribute anything into my parentheses. I can just get rid of them. Plus negative 3 plus I. You could have just written minus 3. Sorry, I forgot to do that, so I left it in parentheses. 7 and negative 3 becomes 4. Negative 2 and I, negative 2i and I becomes just negative I. And that is my answer. All right, write down any questions, comments, concerns you have on that. There's one last thing I want to talk about is multiplying complex numbers, which is a little bit trickier. Only because our, the thing I talked about at the beginning, I squared, comes up in these situations. So in this example, we have 4 plus 3i times negative 1 minus 2i. So again, we're going to multiply these like normal binomials. So I'm going to distribute / FOIL, however you want to do this. So I'm going to distribute these in. I get, or I can write it here. So I have 4 plus 3i, negative 1 minus 2i. I get negative 4 minus 8i minus 3i minus 6i squared. So when I FOIL that out, this is what I end up with. So now this is where the I squared thing comes in. So I know I squared is equal to negative 1. So I'm going to substitute -1 for I squared. So this is where we have an added step here. So I'm going to have -4 minus 8I minus 3I minus 6 times -1. So again, all I did was replace I squared with -1, and now I'm just going to simplify per usual. So I'm going to combine these like terms, and I have -4 minus 11I, and then -6 times -1 becomes +6. -4 and 6 becomes 2 minus 11I, and that is my final answer, 2 minus 11I. So the only added step is, since we end up with I squared, whenever you have an I squared, you need to replace it with -1 so you can end up with more real parts than imaginary parts. All right, so let's do some quick checks really fast, and we'll be done our notes for today. So the two I want you to do, number 1, -6 plus I times -6 minus I. And the second one I want you to try is 2 minus 3I, and then 4 plus 5I. So try those out on your own. I'm going to go over them right now really quickly. So you might have noticed that these are, what do we call them? Conjugates. So they're conjugates, same binomial, different middle signs. These are actually going to factor to the difference of squares. We're going to end up with a completely real number. If you got that, great. So either way, just to show you the whole process, I'll multiply it out. So you get -6 times -6 is 36 minus 6, or sorry, plus 6I minus 6I minus I squared. So if you FOIL this all out, these middle terms cancel each other. You end up with 36 minus, and I'm going to replace I squared with -1. So I get 36 plus 1, 37. So this actually multiplies out to a completely real number, 37. Now I'm going to do the other one. So I'm going to get 8 plus 10I minus 12I, sorry, I didn't draw my lines, minus 15I squared. Combine my like terms, replace I squared with -1. I get 8 minus 2I minus 15 times -1, which becomes plus 15. And then I end up with 23 minus 2I. And that is my final answer. All right, make sure you write down any questions, comments, or concerns you have on any of this stuff so we can go over it together in class.